Okay, today we're doing the introductory material on your project for this marking period, this alternate assessment. The project's name is The Biggest Box for Your Buck. And everything that's in this video should be written in your notebook. We're going to start by, if I assign you a piece of paper that is a 10 by 15 sheet of 10 inches by 15 inch sheet of paper. The concept is that you want to be able to cut 4 congruent squares from the corners, and then you want to be able to fold up this little tab here, this tab here, this tab here, and this tab here to create a 3-dimensional box. It's going to be open on the top. So the more X, or the bigger the corner that I cut out, the more you're going to be taking away from the bottom of the box. Okay? So you don't want this X to be too big, and you don't want this X to be too small. If it's too small, then the box won't have any height, or it won't have enough height. So we have to figure out what is the value of X that gives us the greatest volume for the box. That's what the project is all about. And so for each student, your dimensions are not going to be 10 by 15. Each student is going to have their own dimensions assigned so that your problem will not be the same as someone who's next to you. Okay, make sure that all of this page is copied in your notes. Pause the video if you need to finish writing this down. Okay, so our next question is going to be to come up with a formula so that we can help figure out what that volume is going to be. All right. So again, we're going from a flat piece of paper, and then once we fold up those tabs, we're going to have a 3-dimensional box. Okay. So we're going to answer these questions in algebra. What's the height? What's the width? What's the length? Alright, so we already said that this amount that I cut out here is going to stand straight up. Okay, so over here, what's the height of the box? That's the easiest question to answer. The height of the box is going to be X. Alright, so that's what's going to go on here. The height of the box is X. Alright, write an algebraic expression for the width of the box. Alright, so if the width of the box started out as being 10 when I gave you a rectangular sheet of paper, and then we're going to cut X out of this corner, and X out of this corner. Alright, well, we start again with 10, take away one X, take away another X. The algebraic expression for the width of the box is 10 minus 2X. Alright, so I really want you to pause, write down everything that's here first, and then come up with an algebraic expression for the length of the box. Okay, pause the video now. After you've written that algebraic expression, you can resume the video. Alright, so the algebraic expression for the length of the box is 15 minus 2x. Okay, it's the exact same concept as we did for the width of the box. We start with the length that was given and subtract an x from both sides. All right, moving on. All right, so now we're going to come up with a formula for the volume of the box. All right, so you already know the basic formula for the volume of any box. The formula for the volume of the box is length times width times height. All right, so if we know that the length is 15 minus 2x. Oops, I think we're going to have to make some more room. The length is 15 minus 2x. The height is x. And the width is 10 minus 2x. Okay, so if we just multiply all of this together, we're going to have our formula for the volume of the box. Alright, just to make this look a little nicer, I'm going to take this x and put it up front. You know that the commutative law says that you can do these in any order. Okay. Alright, so the next step, I want you to put this in simplest form. Alright, try this by yourself. Again, pause the video, give yourself enough time to do this. The first thing you want to do is FOIL. Multiply first times first, outer times outer, inner times inner, last times last. Okay, pause the video, give yourself a chance to do this, and then check your work. Okay, so here's what I got after I FOILed. 15 times 10 is 150. Outer times outer, that's 15 times negative 2x, is negative 30x. Inner times inner is negative 20x. And last times last is 4x to the second. Alright, combine like terms. Your like terms are the negative 30x and the negative 20x. Okay, negative 30x and negative 20x is negative 50x. Alright, now that the stuff inside the parentheses is in simplest form, now you want to distribute that x up front. Okay, so x times 150 gives me 150x. X times negative 50x gives me negative 50x squared. And then x times 4x to the second gives me, oh my, we need to change this. It should be plus 4x to the third. So now I've got to edit here. Okay, guys, well, you know that this is a work in progress. 4x to the third. All right. All right. So now we're just going to use the commutative property to rearrange those terms. Okay. So I just put the terms in descending exponent order. Okay. The next step is going to be to use the graphing calculator in order to look at what this curve looks like and find the maximum point on this curve. Okay. So I'm going to have to break that up and show that to you on a separate video. Again, make sure that you have all of this in your notebooks, and look forward to the next video.